Welcome to GDG Dallas, February 2022, building StateFlows in Android with Jetpack Compose. Our speaker tonight is Mohit. He is a Google developer expert for Kotlin and Android. He was an early adopter of Kotlin, also an adapter. Over the years, he has talked in various communities around the globe and has helped many companies adopt Kotlin and Coroutines. He's spoken before with GDG Dallas, and we're happy to have him back. Take it away, Mohit.
Right. Thank you. Thank you for the opportunity. So I'm going to present on how to build state flows with Compose. And so which might be interesting because if you think about it, Compose is a UI toolkit. But it's much more than that. Not just the UI toolkit. You could use it for much more. That's what I'm going to show you in this presentation. And what I'm going to show you is basically how to. There's a library that out there with Square that released called Molecule that allows you to build state flows using Compose. And I'm going to show you how it works, how to use it. So I'll share in this presentation how to use that library, how to go about testing it, and I'll show an example app. And if there's time, I'll actually show you the example app I made, for myself, my personal project. I made it, and it was a lot of work. So I'll just show you. It's all written in Compose, and I'll show you the code. And how about that? So what is Molecule and how does it work? How do you use it? How does it allow you to build state flows with Compose? So, by the way, for this presentation, I will assume that the basics of Compose. So suppose we're we have a problem, we're building an app and we want to display like a profile screen with a lot of information that could be retrieved from different streams of data. And so how would we go about setting that up with Compose when building this type of a screen? And suppose that like different parts of it is from different flows, these streams of data. Like you have like two flows that you have to combine together to actually give the data out to the UI. So you may, in Compose, the way you set up your UI is that all your view components are like your profile screen or any type of screen is a composable function. You make it a composable function. And it basically is a type of programming called, declarative UI, not imperative. With imperative, when you write your code, you have to write out like, go into this UI tree structure, like define view by ID, and then you have to tell it on what UI state you need to update. Whereas here, you just declare, it's declarative. The same idea from React, what are you don't go into the UI tree structure and fetch something. You just declare what your UI is going to be and it will figure it out for you. So over here is an example that I made. This is an example of if you're setting up like a one screen in your app, like a profile screen, you make a composable function which takes in those flows together. Those different flows like flow 1 and flow 2, they give you different types of data. And I'm using the method collect as state, where I'm specifying that, if this is null, like in the case when you don't have data, give me some default value. So with this approach, there are pros and cons. So going about setting up your UI in this approach, you're mixing business logic, you're mixing this logic of setting up your default values with your UI. How do you go about separating this? What approach could you take? So there's an approach that I'll describe, which is using composable functions, which is a pattern I'm going to share with you. And with a pattern that you could take with the Molecule library, which is you create some form of a presenter, which is responsible for generating state flows. And it takes in an events. It takes in, could be multiple streams of data, not just one or two, depending on your use case. And you take that and you generate basically you give that to some component that I'll share called a molecule. And what it returns is basically a state flow. So this is the setup that you would have in your application. You have the presenter that's taking in these streams of data, and it knows how to generate a view state. It knows how to generate a view state, which is basically what should be the state of your UI. It knows how to generate that view state, a model. And you give this presenter to this component called the molecule. And we'll look at what molecule is and how it works underneath the hood. And what it does is that it uses base compose of API to be able to create a state flow. And that's that's what the approach is that I'll show you. When you look at this approach, you might think that, I don't want to use a presenter. I want to use a view model, like a Jetpack view model. I'll also show you how to do that also. So the purpose of this library that's, is a molecule is to build a state flow using compose, with this approach. And it begs the question, it follows up with the question, what is the difference between compose and compose UI? It might seem a bit confusing, like how could you use it to generate state flows? So there's a difference between there, where compose is the base compose API it's a compiler plugin. It's a general purpose tool for managing a tree of nodes. And in the Android case, when your UI, each node is a view or a view group, etc. So it's a general purpose tool that could be used for a lot more different things than just building a UI toolkit. So the nodes in here are basically could be anything. And the base compose library provides you with an API to be able to manage this tree of nodes. When something updates, for example, a node updates, it knows how it will recompose itself. So when a compose UI is different, it's a UI toolkit where, as I said, each node is a view or a view group. So there's a distinction between those two different things. And what molecule does, the library, is that uses this base API by compose to be able to generate state flows. And so there are two resources that I recommend that go more in depth into what I just discussed. There's a Jetpack compose name by another name that discusses more of the history of how the naming came about. And there's also compose from first principles that talks about the base API compose, like how it it's a really nice talk that was given about a while ago on how compose works. The base API, the base layer, how does it work? And so molecule is a compiler plugin, right? And it continually recomposes based on a clock that controls when recomposition occurs. So I'll explain that in more detail. So so how do you use this molecule library, right? As I was showing you the approach, how do you go about implementing it? So in this scenario here that you have an UI in which could be shown, the data could be retrieved from using multiple flows. How do you set that up? So the way the setup will be, you have your view, which is your composable function, and it's going to take that state flow, which is created by this library. And then what we're going to do is, first step is to create a presenter, basically that knows how to create some state based on the streams of data that it's reading from. So, and this stream could be multiple, 1, 2, or 3, and you could combine them together and have your logic in there. So let's start with the presenter. The presenter is going to be a composable function Now it's a composable function, but its job is not to display some UI. Its job is to give you back a model, a view state for your UI. So the model in this case would be, for example, if I displayed like a profile, it might be like loading and then some data class, which has some data to display. And so this compose function will return that. And what it's going to take in are both of these streams of data. So it's going to take in, for example, like if you're working on a social media app, it might be displaying a list, you're reading from a flow, which gives you posts or the number of likes that you have for your content. So what you do is that you read from this flow using collect that state. You have your logic for your default values, if it's null, or the default value of 0, for example, for your likes. So you're reading from both of these flows, and here you have your logic of how are you going to generate your model. So if it's null, for example, it'll be loading, else it's going to be a success. So this is a very simple example of a presenter that takes in basically 2 streams of data and knows how to generate a model. So this is in a composable function which does that. So we are going to give this composable function, and we're going to give it to molecule library to be able to give me a state flow. And the way this works is that the first thing that you need to do is to define a coroutine scope in order to do this. And so this is what we're going to do. I have dispatchers.main in my coroutine scope. The second thing that you need to do is specify a frame clock. And the frame clock is important because I'll show you later on is that it allows you to control when recomposition occurs. So there are 2 different types of frame clocks that you could use for Android is Android UI dispatcher or broadcast frame clock. So you need to add that to your context. So, as you know, like a scope has context, which is a set of elements. Like it will be your coroutine job. It's going to be your dispatcher. It's going to be it's going to be in order to add something to it, you would use the plus operator, and I'm adding here a frame clock basically. So what you could do after that, what you want to do is do scope dot launch molecule, call the method, and launch molecule is an extension that the library provides on a scope to give you which creates the state flow internally. And so the way you do it is that this scope that you made, you're going to do scope.launch molecule, which is the extension that it gives you. And in the Lambda, you pass it this composable function that takes in these streams of data and knows how to create a model. And what it returns is a state flow. So and when a recomposition occurs, and it will push things out to this state flow that your view is going to be listening to. So you have a state flow here for your model updates, and your view is going to listen to it. In order to set that up, this is going to be your view. Now it takes in one source of truth, one state flow, which is going to be your state flow of your models. And then with that, you're going to collect that state from that, and then define declare basically your loading and then your success or your error. Well, that's the setup. You have your view has this one source of truth, and anytime recomposition happen, like that state flow will update. So in this setup here, what if you're using a view model, not a presenter? You could set up with a view model, like a Jetpack view model, also this state flow using, a molecule, which is, there's an example in this famous app called the TV app, because it's about TV. So this is the app in which, this is an example app in which has lots of really nice patterns, examples of it. There's an example of using molecule. And there's an open PR actually for this as a nice example, which you have your model basically. And inside of your model, you would do the same thing. You would declare your scope with your frame clock. And then inside of it, you would have your state flow and create it in the same way, like take the scope, call molecule, launch molecule on it. And then inside of there, you would have your same logic that you had like in your presenter and your composal function, which is you listen to these streams of data and then you generate a model. So, and then externally, your view would be, you would give the state flow to your view, a read-only version. So this is in here, and when you look at the TV app, it has an example where it uses something called launched effect, where it has to listen to other flows, has some side effects in there. So you could also utilize that and take that into account when generating your model, your UI model. So this is how you could use it with the Jetpack view model, this pattern. So we looked at the basics, two different things, which is how to set up a presenter or view model with this approach, and how to use this library to generate a state flow using launching molecules. So how do you go about testing with this approach? And what I want to test is that, like, when are the right things like pushed out to my state, when like the streams, when I push things out to my streams. So for example, like, what I want to test is that, does my presenter produce the right UI model, the right view state, depending on what these flows like are have. I'm pushing what is giving. So that's what you want to test there right here with this. So let's look at, this library called molecule. There's another library by Square, which is a Cache App called Turbine. And it helps you to test things. It helps you to test flows, provides a nice API for you to do that. And it's built on top of that. So the way you implement this is that they provide a special module for testing for molecule. And then, so let's look at a sample test case, which is a success case, a simple happy path, which is, so first thing you would do is that these streams of data that you're ingesting, you would create a shared flow. The reason why you create this is that you could push things to it and then test whether you get the right model. So this library provides you with a method called test molecule. You're going to give it the presenter that you made, your presenter, and it takes in these shared flows that we made right here. So then what you could do in this Lambda is that, for example, you could do an assertion. So a wait item is provided by Turbine. And what it does is that when you read a flow, it pulls out the first item that's emitted in the flow. You want to pull out the second item, you call a wait again, until you want to verify that everything in the flow got emitted, you call a wait complete. So there's also wait error. Though a wait item is going to pull the first UI model, which is going to be loading. But what if now I want to test the success case, right? And what I'm going to do is that I want to push something to one of these flows, and then just do an assertion. So the way you do that is that post.emit, emit some data, some fake data. And you would also do that for likes. And then you would do, an assertion that, that it was a success using a wait item. So with this, so this is the setup, very simple setup where, I'm using a fake and pushing the fake and then doing an assertion on my view model. So on my UI model. So this is a simple setup of how to go about testing, your state flows with this. So that's two things that we looked at. Now I want to go more in depth and look at the internals of how this library is set up and uses the base API. And so what it does is that this base API, there are ways you could hook into recomposition. And there are 3 different steps that it takes. And I will show you these 3 different steps. So the first thing that what it provides is an extension called launch molecule, this library, basically. That's the API of this library. And which takes in, a body, which is a composable function. That's the presenter composable function that you're passing into this extension. So what it will internally do is it will create a state flow that's going to be returned to you. It creates internally a state flow because it needs to be able to push things out to it when recomposition happens. So it's creating this state flow and providing this to you. And the way it works is that internally it makes this state flow. And then you'll see in the emitter is going to call this emitter, right? When a recomposition happens and it's pushing it out, updates, basically. So when it does this, the first thing that it does to make this work is that it sets up something called a recomposer. And so the way you set it up, this is something provided to you by the base compiler, library, the compiler plugin, and you provide your coroutine context. And the second thing, there's a method called composition that you're going to provide the recomposer to. And then the next step, which is important step, is to schedule, hook into recompositions. And there are listeners that you could set up to hook into that. The way you do that is that you first, it launches a coroutine, and then this right here will await the invalidation of any composers, associated composers. You could have multiple of them. So there is a class, an API that this the library provides, Compose, is to register a global listener. When does this listener fire? It fires when a state object is modified, and it informs you to run your own logic, basically, when that happens. And so this is the most important thing it does, is registers an observer for that. And the last thing that it needs to do when this gets fired is to be able to invoke all the logic you're providing to it as a composable function in the presenter, and this is how it does the composition, set content, emitter, body. So that body, as you remember, was a composable function. It was a parameter that was given part of launch molecule in that method, and it's executing that logic. And what that's going to produce is a UI model, basically. And then it's emitter, when it calls emitter, is pushing that out to the state flow. That's how this works underneath the hood. So that's the internal. The source code of this library is not really a lot. Just it's easy to understand and follow. So I want to show you now an example app I made that I worked on. I worked on it because it's good to work on things. So I worked on it just for learning purposes for my own. So what did I build in my library? What did I build in my app? I built an app. How would it be like, building a compose app that's fully composed, and how would this library look like when you're using it in an example app? So in the app I built has multiple presenters, 3 different screens. Well, this is the app I built. And I built this app because I personally like to play golf. So why not combine 2 things you do? So I basically wanted to build an app that could run a simulation. Why would someone want to do that? I don't know. It was fun for me. That's why I did it. So basically, I wanted to do that because I want to make it complex enough and not just build an app that just displays a list of things. So what is this and how does this work? So there are 3 different tabs, right? There's the scores tab of players and weather. So what I'm doing is I'm trying to simulate a past tournament that was held long ago in 2019. And I have the data for that tournament, pieces of it. And what I do is that I'm using coroutines to be able to generate basically at certain speed that I specify on the scores. So as the time ticks by, I have a virtual time that ticks. And each time it ticks, it shows you the scores basically in this leaderboard. It shows you the scores, and the scores keep updating basically as the time goes on. There's a flow that gives you the scores basically as it's so I guess the benefit of that of solving that problem is that you have to utilize coroutines a lot. So this is an app that has these three different screens, and these three different screens are represented by a composal function. So imagine you were building an app that has multiple tabs, and you would represent each of them with a composal function. And this app is multi-platform. I wanted to learn iOS, continue learning iOS, so I built the iOS and the Android app. And they share something. They share things, and they share basically components that allow you to generate this data. And a lot of it is coroutine stuff. I was always wondering what it'd be like ingesting coroutine flows from iOS. Let me tell you, it's not that good. Well, I mean, it's somewhat good. So it's and I built the GraphQL server that I'll show you. So the setup is basically you have a view, you have a presenter, and then presenter takes in a list the events, and it generates a model. So the profile the presenter, similarly that I did before. How do you set that up? How do I set that up with Dagger? I wanted to use Dagger and just not just create like functions, like composal functions. I wanted for them to be able to participate in DI so that I could give them utilities. So what I did was that in order to set up this pattern, I basically created these classes, these presenters, which have a composal function to present. Each presenter follows this pattern. And when you think about it, each presenter follows this pattern, how could you extract it out? How could you extract it out? So, what I did was that to extract this pattern out for each of my presenters, I created an interface. And there was a reference to this interface in the blog when Molecule was released, but it didn't have an implementation. But I was curious, how would you build this? So this looks good. It's a presenter. It takes in two generics of event and a model. So each of the presenters, have this like a contract that they abide to, basically. So each tab has a presenter and that abides to this contract. And basically, so you have Molecule presenter that it inherits from. So each of them have a present method. So when you have this, right, how do you launch molecules and where do you launch them? So that's the question. So the way this app is set up is that I'm using the navigation. They have navigation support for Compose, and I'm using that, and I built a navigator. This composal function that knows how to do the navigation. The way navigation works in Compose is that you specify what are the composal functions that you could route to, and these are the three different composal functions when you click on the tabs that you can route to. So my navigator takes in all the three different state flows, and I create them basically at the root level, at the activity layer. The architecture that I explored is, how would you build a compose app? You have the one activity and everything else is a composal function. What are the challenges of building something like that? So basically, in my set content is where I basically launch my molecules. I set up my navigator, and in there, at the top layer, I inject my presenter, and then I launch my molecule, create these state flows for each of the different tabs. So the scores tab, the players tab, etc., and I pass them in from the top to the bottom to my navigator, which passes it to the different views that needs to read from them. So in this approach, that's the approach I have, like one activity and everything is a composable function. But the problem becomes when you have multiple, if you have a larger app, right, but number of composable screens, this doesn't scale. I mean, my main activity be so big. And so the open question is, what I'm still exploring is that how do you better architect that, right? Because how do you do essentially DI with with that setup? How do you better manage that? So that's an open question. How do you set up launching, like creating these state flows with this approach? So I'm injecting all of my presenters, the dependencies that these different screens need at the root layer. That's a challenge. So I had a lot of, with my project I was working on in the community. Bill is a nice guy, works at Square, who I reached out to, and I shared it with him. My project, gave me feedback, because he's brilliant. And he said, you don't have to, I don't have to use molecule. My example is simple, but I don't have to use molecule. I could use the pattern that it has, which is this presenter style pattern, which is simple, which is a reply that someone had, with an example code of what I was just showing you, like a screen that takes in the presenter, like in events, and you have it in there. So I could, like, with that approach, just re-architect it using, I have my flow there, and I give it to my model, and then I could give it to my scroll screen, also do it like that. So that's my presentation. That's my example app and how I built it, and it was good, good for exploration. So I will link out in my slides. There's a blog article I wrote, which I share more in depth what I just spoke about, which is called Using Jetpack Compose and Molecule Library. Also have a link to the molecule library itself. There's a PR open, which hopefully will add more examples and patterns if you want to use it. I guess the benefit of exploring this library was seeing a pattern, a way to use the base, compose thing. Even if you don't want to use it for building state flows, you could just get an idea of how to use the base compose API for a use case other than UI. So I want to say thank you. If there's still time, then I could share in code my project if you want. If you have any questions, then you could follow me on Twitter. Hey, it's Mohit, or you go to my website. My website, I share my knowledge on stuff other than Compose, like coroutines and gRPC, etc. I want to say thank you for having me once again. I hope that was helpful. Thank you.
Woohoo! So awesome sauce! All the sauce. So saucy.
Anyone like to see Mohit's code as a demo? I think you said you could do a code demo. I think that'd be nice. And maybe we can take a few questions if people have any.
I want to start with just sharing, how the backend server I built and the challenges with that. Then I'll share the Compose app. So let me share my screen. So you'll see here is that I'll zoom in. Give me a second. So this is a GraphQL a project, right? This is a GraphQL server. So there is a library by Expedia that allows you to build GraphQL servers. And why did I use a GraphQL server? Because in GraphQL, how do you listen? One thing I wanted to explore, how do you listen to a stream of data? You could, there's something called GraphQL subscriptions. And, but that's something I wanted to explore. But in my use case, that's good for if you have events that are really, really fast, one by one, after the other. but I didn't do that. So I didn't use GraphQL subscriptions for that. But this was good to learn how to build a GraphQL server. So this right here, what is the challenge, I guess, here? So when you look at what is the data that I have, the data that I have is really sparse. Just think of it like a graph where you have points, like 4 points, but you have to draw the line in between them with some certain assumptions. So this is the data, JSON data that I have for all the players that were in the tournament. And then I have data on when they started to their tee times, when they started to play. So, and then I have those are the tee times, and then I have basically the scores, right, for each round that they have. Right. So that's my data that I have. So you have to be able to crunch this data, right? So when and piece it together to be able to give it to the UI for this server. So one of the hardest parts about this is crunching that data together, right? Doing the optimization. So for example, the thing which drives this whole thing, in GraphQL is that this right here is the single, this is the API where you define to the app what will be the queries that it could make. So this is a service, right? I'm inheriting this query class in here, and I have different repositories for different pieces of data. And each of these allows me to get the scores, the weather, and basically the tournament info and players. So for example, the players is the easiest one, where I have a repository that I just call get players on. And this goes out, uses Mashi just to read from the JSON, convert it to an object, and give it to you. So the most interesting part is creating the snapshot for a golf tournament, which is this scores method, the scores tab. When you call that method, this right here takes in a timestamp and it generates some data basically from there. So you can see there's a class called round generator, and this is the whole piece of code that basically the most complicated piece of code, which has all the logic to be able to create a snapshot based on a timestamp of what the scores were like during that time. On the client side, in the Android app, you would pull this query, you would pull this method right here. So you would call this method like, at some time interval and give it a timestamp, right? A continuous timestamp to get a snapshot, basically. So that's the point. That's the simulation. So in here, what I did was that. So this is right here the GraphQL server that's built. So how does the Android app use it? So I'll share the Android app, which is a multi-platform project. So this is the Android app, and so this right here is a multi-platform app. And when you build a multi-platform app, the shared folder has everything, all the components that's going to interact with that GraphQL server. So this is the setup. There's an iOS app, there's an Android app, and then there's a shared. And then there's common, Android. So in here, I have in my common, my GraphQL queries that I'm going to make, which is here, like get the weather, get the scores, get the tournament info, etc., and the players. And I have my schema in there also. So GraphQL has support. Recently, they added support for multi-platform support, which is nice. And in here, basically what I have is my simulator, which is I have an interface that my iOS and Android app will utilize, right? And which is basically this thing I'll show you right here. This is the interface, right? This is the interface that allows you to get different types of data, simulate the tournament based on some speed. So this returns a flow. So when you look at this, when you see this code, one of the things that's weird is that this is not a flow, this is a C flow. So one of the challenges of building a multi-platform app is that basically I had to do this. I had to create a wrapper around, flow. The reason why is that if I had over here a flow in the iOS app, it doesn't really look good. And I mean, it's not really, it's a lot of code to be able to ingest it. And I want to make it more idiomatic, Swift idiomatic, to be able to, this is also used in the recommended approach. You'll see this is also used in the Kotlin Conf app that you could search online for. So in this, how is this being injected by the Android app? So this is what the shared library provides. So the Android app basically is, I have my presenter here that I showed you, and let's look at the scores presenter. So first, before I do that, let me show you my main activity. This is my main activity that I have here, which sets up my navigator. So in my navigator, you'll see I have my scaffolding in this bottom navigation item that I have. This is a way to specify, how to do navigation. And in here, what you specify is a nav host. The nav host takes in composable functions for each of your screens. So I have in here, this is for the score screen, this is for the player screen, and so at the top layer, root layer, you set this up where you can navigate to different screens. So in here, I'm utilizing, I'm giving it the shared component from my multi-platform. This right here, that's multi-platform, this interface. It allows me to get different types of data. So when I give this data down, so for example, in my score screen right here, I give it down, I have my tournament info section. This is a composable function. And then my score section, I basically take that model and then I specify, what I'm going to show for success, different error. So the presenter here is what you saw right here. I have launched effect in here. This is, as it takes in my flow of events, from my multi-platform library, and I generate a model from there. So that right there is the setup of something I worked on that it's open source. I shared it. You could look at my repo. And that's it. And anyone have any questions?
So this kind of brings up something I ended up talking to a couple people that about potentially using this with some other things to really pull pretty much all the code out of view models, or at least the standard like Android view model, so that it's truly just state. Especially because, from the Compose side of things and Compose UI, it can get pretty darn hairy, especially on like your complicated views, right? Where you are like reusing the, general composables, right? But like you still have to pass the view model around like crazy, and it ends up just being not a pretty thing. We haven't had a kind of good solution come around for non-trivial applications. And I was kind of wondering what your thoughts were on that, or if you've kind of done something along those lines with Molecule, just kind of generally.
No, I don't have any thoughts on that. I'm still exploring. I don't have any definitive answers. With the Molecule approach, obviously you're not passing in the view model itself, right, into the composable. Is more of a flow, and that's it. I mean, I don't have a definitive answer on approach.
So to Stacy's question, so I've been working with a lot of view models and MVVM and data binding. One of the things we're trying now is just writing an extension function to the view model called toState that returns a data class and any one of the live datas that you had in your view model that you used to data binding, we're collecting a state in that composable. And then we pass that data class state object, which is not a flow anymore because every piece within it is a state. So the observable's there, and you don't have to have an observable at that connection layer because the sub pieces are observable. And we just pass that straight through to the screen content, and you have state available there, and you're not passing the view model anymore.
Are you when you said live data, do you mean literally the live data library, or are you talking about just live data as in other flows?
Flows or live data. The idea is that you have your view model, and if you're using data binding, you've been connecting observables to your layouts. And so we're migrating an existing app. So this really applies more in that kind of context. But so in the fragment, for example, you apply your theme, you do your set content, whatever, you have access to that view model there. And then you just write an extension function for the view model that called toState, for example. And it returns a data class that has a series of state objects within it. And the data class itself is not observable because it doesn't need to be, because every element inside of it is observable. So there's no, and we're not doing the sealed class technique. Now, it doesn't have the sealed class where it's a presenter. You'd have to use that as a flag or something internally. But since you don't do that, each one of those singular observables solves the problem. So it's more of a MVVM style than an MVP or an MVI style, where since with MVVM, you're directly connecting to the sub elements of your view model directly, and you're not pushing an intent or a presenter type pattern. You just connect those directly to state. Your screen content accepts a state, and then you can actually have all of your compose code in a separate module. You define that data class in the same file as your screen content, and you have one converter function in your app module that can convert from view model to state, connects all the leggings. And then if you have like bi-directional stuff, you just have a Lambda that you connect to your own changed for text field or whatever, right? And it does a post to the view model's mutable live data or mutable stateflow or whatever.
Yeah, that gets a little like hairier because at least for the stuff that I'm doing at the moment, we're trying to make sure that it's as pure Kotlin as possible, rather than using some of the Android specific libraries on that stuff. So no data binding.
Right. This is there's no data binding, right? This is not data binding. This is a replacement for data binding.
Got it.
Literally, let's say you have a view model and it has live data or state flows in it that you were binding to historically. You would extend that in your app. You would return that extension function would return your state class, which is what is passed to the content of your composable. And since that state class doesn't need to be observable because it doesn't need to be, because you're not in VI or MVP, you don't have to do any other connections there. So it's a simple extension function to convert those piecemeal across. And you're kind of doing the same thing, except with the seal class here, you get the loading flag, lifted up a little bit, but you're still, connecting through collective state for the actual data pieces, which would be identical. And all that works the same. You end up with a state, a composed state object with data in it that is fed. And we've been able to do that without altering our view models at all. We could just completely leave the view model, not touch it at all. It uses the same DI it was using originally to talk to domain and data and all the other stuff, but it's just an extension function that converts or connects that view model to a state object. And of course, then and since the compose is in a different module entirely, it's standalone. And then it's just a state object. It's a data class with a series of states and then lambdas for communicating events back. And then that is fed directly into your screen content function. And then, recomposition happens down below that.
I got it. Yeah, no, we have the same kind of layer separation on our stuff. So simplified way to describe it as data domain and UI. So for everything. Repository services, communication state, definitions, the whole 9 yards. So, but I was blessed with relatively greenfield. Compose all the things.
Yeah, that's the best way to go. I'm in a big app that we started off with, MVVM data binding, and it's time to redo, and basically we're starting with, let's replace all the layouts one at a time. So it's okay, do a screen content, connect the existing view model with the function, and then let it render.
And not to interject too much on that stuff, just I really, really strongly suggest on your compose layouts, because order of operations is a thing, especially on compose, to make sure to check out your stuff in the developer option tools. Check out all of your layouts there, because it's going to tell you if there's anything screwy that'll affect your accessibility stuff. The other thing I kind of found is on the compose side, it seems to do a very different thing in terms of its overdraw and redraw, because of the way that compose actually works, that it is constant. It's like a constant redraw overdraw situation. So like everything comes up as a 3x for the most part, just because it does the compute, the draw, and then the state piece to it. Like it, I don't love it, that part of it. I'm just like, oh man, there's gotta, but I can't find a real performance hit. It's just my screen looks red, and I don't, a little part of me is telling me that don't seem right, but apparently it is right. Is at least what I'm kind of have gotten on that front. But yeah, do take a look at some of that stuff. But thank you so much, Mohit.
That was really cool, yeah.
I've been like at the very first, before Jake wrote his, his little ditty on it, I was following some of it, and I was like, I wonder if I could use this plus this other thing and just kind of schleff this off and move that through. And I love the KMM and KVM stuff, because I mean, especially when you start really thinking about abstracting so much more of your data layer. And, Kotlin JS, at least for a number of things, I'm still mad that the compose for web is totally different. Like, what? Why did they do that? It makes me sad. I'm like, why did you just make it different? You could have just done it in the compiler, right? Like, come on. But what else? Thank you so much, Mohit.
Well, thank you.
Yeah. Any other questions?
Yeah, I got something out of left field, and you can cut it out of the recording if you need to. But, from the guy who doesn't know Android or anything, I was just thinking out loud. What about the whole like actor model and letting actors interact and encapsulate their state? Where it's sort of a different approach. I hear people talking about, like a different way, even on the web, of setting up your app where they're bringing back the actor model and setting some messaging where they're messaging each other and then dealing with the state themselves that they own. Does that make any sense? Or scratch any thoughts there?
With the actor model, could you describe more in there? Like, is that more like a web stack pattern?
Yeah, like
how would you set it up?
What were they using? Were they just using service workers and some where most of the time it wasn't a problem unless it had to there's one particular scenario, but basically part of the UI is you separate the UI like I think they used a clock, for example, and they had something that was reporting the seconds, and it was just messaging back. So the events, were just messages, kind of more, not less class-based, more, a little more functional. But they're saying like the old actor model is actually kind of interestingly being looked at as like appropriate for the modern needs of managing the state in the UI and that's kind of that's barely my understanding of it, if that makes any sense. Maybe I'll go do some little more homework and provide better commentary on it. But I don't know, for some reason when I was looking at, is that data flow there in your architecture? That's all one-way data flow, Is that what's happening in your
Yeah.
flows? Okay,
Yeah,
so
one
it's
way.
yeah, so it's all one way. Okay, yeah, and so in this, it wouldn't be one way, and you I don't think you'd have binding per se, like I think Colin was saying, but you would have an actor that owned a part of the UI messaging another actor that owned a different part of the UI, and then each actor encapsulating their state, therefore updating the UI. I think that makes sense.
So Raul, when I'm also studying, Compose, and I found this one nice little video from a Google guy, Manuel Vivo, and also like if you look at a lot of the docs, for Compose, one of the mantra they kind of keep saying is like, you want to make these composable functions like stateless. So they say state in, events out, so that's how they're managing it. So meaning like, there's no mutability, no state within the composable itself. You're passing the state in, so it's gonna render like every time the same thing. So like you really don't have to do too much worry about like, hey, is it gonna change the state? Because you're giving the input, the state in. So, and I think Compose does a really great job of optimizing so that recomposition, kind of is optimized. So, even though like, what Stacy, I also noticed, that if you put a breakpoint on your composable, it's hitting it like a lot of times, and I could not like trace it through like what was the other method, but it's somewhere deep within Compose, and that's that recomposition. But I think it is doing it smarter kind of, and what they said is that anything like, for example, like let's say you had to edit text, like something you're editing, out of that, you generate an event that and pass it out, so it literally becomes a Lambda out there, and then you kind of do that. So that's how the Google's recommendation is, but again, I'm also learning it. It sounds all great for like a simplistic things, but when your UI and the whole thing starts getting bigger, it's just like more and more we learn. So I like this molecule right now. We'll look into that and kind of see how different layers kind of break out.
Lots to think about. Thanks.
The biggest thing that would be with Compose and the different actors, I would guess, if they were talking to each other, would be that each composable function is idempotent to the point where there's no side effects. So you can't pass in parameters and have them update have that function directly update a side state that is not passed into it. It would have to go up through an event and then back down to something else. Because like Harish and Stacey have said, that it might recall that function automatically every second during an animation, or every frame during an animation or something like that.
I will say I like some of the new animation tools, but crossfade is like if transition manager actually worked.
Right.
I am saying this on public, whatever, okay?
And it's just like I made a data binder to get it automatically. But yeah, it's way easier to use in Compose.
I'm old school. Give me object animator. Give me like 50 lines of code to write, and I'll make it go. Woo!
Pull the integers out of the loop and store them at top level.
Oh God.
Oh yeah,
I'm feeling called out over here, Colin. I'm gonna go ahead and say it.
I've been there. I like that too. It's not real animation if you don't have to use sine and cosine in there somewhere.
Let me just put const val across a bunch of things.
Oh yeah.
Let's go ahead and just assign this a companion object just to throw some extra stuff on it, Although now I definitely find myself using a lot more sealed classes on that stuff.
I was wondering, wanted to ask everyone a question because so if you were setting up navigation, suppose it's not a Compose app, it could be a non-Compose app. And how would you to set it up in a testable way? Like suppose like you have the setup of an activity view model, you know, etc. What approach would you take this? And you want it, you suppose your view from your activity, you can navigate, or sorry, from your fragment, you could navigate the different fragments. And how would you, what approaches would everyone take to set that up?
So you can do some stuff in unit tests, but it's not going to give you an accurate piece of what you're. Sorry, she's not happy. Hi, baby. You don't want to be in your chair. You're like, no, mama. Okay, got it. So with regards to that stuff, so you can do some unit testing, but all that's going to do is just give you values, start and end. You can fake out some, you know, intermediary values, make sure at least your functions are, you know, playing nice, all that kind of fun stuff. It gets sketchier on espresso testing, but you know, I don't think that's anything new. I think pretty much all espresso tests get kind of sketchy at runtime, or at least if you start doing any, you know, decent amount of them in consequence. So it gets different depending on the kind of animation. So if you're just doing time-based, you can fake that out, just like you do, you know, with any kind of like, you could just fake it out with a counter, basically, and the same.
Bouncing around just cut me.
Okay.
Really bad for some reason.
Okay.
It's not even open.
Hi. I know. All right. And
Just thought you'd like to know.
I don't know why he needs to show me that. It's like his finger's all bloody. Okay. But basically, so you can have ones that are like time-based, right? So it does this to this over a period of time and then fake out the timer. That's one way to kind of get your stage pieces on the espresso side of things. The other one is kind of your value animator or value-based animator, which then if you're doing ones where it's like touch-based or something else like that, you're gonna have to almost like kind of, on those I get kind of lazy. I might do like a record macro, like the record espresso test thing, and then just kind of zhuzh it from that point on, because you're just doing a touch emulation, right? So, but both of those are still valid if you're doing, well, I mean, you can still do object animator on compose objects, but I mean, that's because you can do that on everything. So I have a old presentation on all the like object animator stuff and all that kind of thing. It's all still valid. None of the animation like libraries always, like, they'll have the same name but actually do different things. Especially like some of the scale ones or rotational ones. You're like rotate, and it implies one means one full rotation instead of like a degree of rotation, but the other one is looking for the, it's all over the place. So yeah.
If you had a setup, like suppose, like as like Harish was saying, you have a click listener, right? And when you click on the button, you want to navigate. So obviously the simple approach is that you do, you know, find nav controller and then nav2. Suppose that you were to create a method in your view model and push that event out to your view model. And then you had a navigator class, right? That basically you injected into your view model, and then your view model told it, hey, navigate to this. In that setup, what do you think about that? What do you think about that setup? And how would you, for this navigator class, if you're using DI, how would you inject, is it possible to inject the nav controller into it?
Ooh, depends. Are you rolling your own or using the Android one?
The Android one. If you had a Dagger module that just returned that took in like has a parise method with an activity and took in
I've never
return.
Wait, no. No, I've never actually done that with the Android one. So I've done it with the roll my own situation. In fact, actually everything was injected. The like all the stuff, you know, for the constructor and everything was injected, and then the view and the like the control system was injected, and then the actual like navigation and control system was an RX custom implementation.
Yeah.
So man, I just don't know if it would play nice if you tried to inject the nav controller, because it basically lives with that like nav activity piece.
Yeah.
I don't know if you can abstract that in a nice way.
One of the things I tried to do with my view models was just not. So view models are Kotlin, they're not in my world, right? View models are Kotlin, they're not Android. If you're bringing in context, if you're bringing in any Android code other than maybe like live data, because you have to sometimes, then it's not a view model anymore. It's mixing other stuff. So we would literally just call an event, and that event would do something in the fragment, and the fragment would call the navigation. And that makes your view model an entirely singular unit, which is ideal for unit testing. So by separating it out, I wouldn't even let people in my teams inject view models to each other. They would have to go out of the view model, connect an event, and talk to another view model. And the idea there is that view model is a singular thing, and it's allowed to talk to domain and offer up, and that's it. It offers up it offers up things to be bound, that can be bound to or connected to now with Compose and events, but that's it. That's all it can do. And it's, you know, it's trivial to unit test it at that point.
That's a good approach. I guess I meant not injecting directly the nav control in the view model, more like you have a special class to call whatever, you know, app navigator or whatever, and then that takes in the nav controller in the constructor, which has methods. So
I would say at that point, you're losing some reusability of your view model. For example, say you wanted to use the same view model on multiple screens. Does the view model itself need to be concerned with navigation, or is it more concerned with letting the pieces of code that are concerned with navigation know that a button was pressed and that it's time to do something in response to that?
Right. Yeah, that's a good point. So in this approach that you're describing, you would have a view model with like one state flow, especially just for navigation events, right?
Mm-hmm. Or possible, just, yeah, it's time, like the next button was pressed. And then the fragment in the onCreate view listens to that and says, hey, I know that I'm hosted this view model, and under this situation, I'm supposed to go here. You know, you could make it more functionally named, but the logic is still there. You trigger a live event or a shared flow and fire off the navigation event.
Yeah, that's a good approach. In addition to that, another other question I had was, what was my other question? So if you were like interacting, like building an app that you wanted, you were, you know, maybe using Room or SQLite or something, and interacting with some database, right? And what approach would you take? Like you had someone from your view model, you needed to make, you had an event that was fired, maybe it was a click, and based on that, you need to update some row in a table and or column. And would you go take the approach of injecting the DAO into your view model? Or would you build an abstraction that just hides away the DAO?
Every layer is abstracted. So that's where I kind of got, where I was just applying like clean architecture to the Compose module as well for the converter functions. So I have a translation layer. So I have UI models for app, I have domain models, and then I have DTOs, and every layer gets a conversion function, and none of them do with each other.
That's good. So obviously there's a trade-off in that approach, right? It's verbose. How, I guess, what would be, if someone were to have that argument, brought up that counter argument, what would be your counter argument? Or is there like code generation that you utilize to be able to rectify that?
The argument I would say for against, it's slightly verbose, but if I have a problem where I say where let's say I make a change to my data layer and all I have to do is adapt my singular converter function for that DTO to the domain model, and I'm done.
Right.
So I also what it does is, via clean architecture, you're isolating the changes you have to make to a particular module. And each module and each piece of code is 100% unit testable because it's not allowed to talk to anything else.
Right. When you utilize clean architecture, one approach is that you have an interactor that has some invoke method, right? How do you feel about that approach? Do you utilize that?
Yeah, I'm use case interactor all the way. Okay. Every communication to domain goes through a use case. Well, sometimes you can cheat occasionally, but the idea is if you are communicating through something else that domain connects to, then you are by definition interacting. And that means, so if you have one module over here and domain sitting in the middle and you want to talk to something else on another section of one of those outside rings, you can't go around the ring and interact. You have to go all the way to the center, as many layers as you need, and then back up.
Okay, yeah. If you had obviously many different apps, they all interact with some third party like analytics service, right? Is that, would that be a use case or for like each event? Like, would you make a use case or one use case for tracking, one use case of tracking event A, another use case of tracking event B? Would you set it up in that manner?
I wouldn't do it that small. I mean, I would first off abstract all of your analytics as much as you possibly can so you can click in and out, and then build the layer to that. I would say probably multi-module abstraction, right? So you end up building an analytic module, and then I like to separate out all of the other extra pieces for all the other, all the other libraries I might be sending to, right? So then get even more granular with vendor code if you can, especially if you have to load it locally. So then really encapsulate it if you can. And you don't want to have to, so for each of those use cases, I would just be calling into the interface for that analytics module and then doing the actual work from the analytics module itself. So then have the analytics module manage all of those individual interactions and use cases itself. Because all you care about, honestly, is a solid interface, right? And you don't want to have to come back through when they're like, well, I want to change this to this, or I want to also add Firebase monitoring or whatever else. Then you already got it. You just click it in, and that's the same thing for everything. I'm a big fan of modularizing as much as possible an interface. And slapping interfaces on it, because then that way you're just, the same thing with it keeps your models safe so that, if your network layer changes, if your API response changes, then you're not having to repopulate everything from the bottom up. Does that make sense?
So, yeah, that makes sense.
Maybe a sealed class in the domain that represented your events or something like that. So that they're available to all the modules in case you wanted to have event logging from other places in the repository or anything like that. So
another question is that when you create, you're building a feature, you have a view model, right? And suppose you have to combine multiple streams, right? And that could be multiple. Would you inject multiple interactors, or would you create a composite interactor, one interactor that takes in these other ones?
I'm using Coin, so I can do the property
Service
injection, not
locator.
and I could do the very fast service locator and not constructor injection. So my constructors don't get crazy, and
Yeah,
I
that's
do
the
a lot
that's
of
the thing.
DI there. Yeah, so I'll have 5 or 6 sometimes, and then combine the flows using stateflow combiners or something like that.
See, that's the deal with. You got to play the trade-off game whenever you're using and to a certain degree on the service locator side too, right? So you could totally end up using both in the same application because they both have things that they're particularly good at. I would not want to do things individually if possible, but at the same point in time, you have to remember that either way, you're still going to end up with the same amount injected. It's just going to be what's prettier.
Yeah.
So, just, from that standpoint too, on the DI side, like, I just try to be extra conscientious of how much I'm actually injecting to really kind of minimalize some of that and make sure that where it is being injected, it's like in a consistent place, right? So if I am injecting things, I'm gonna inject it at the model or a data class. I'm not gonna inject it anywhere else, right? Or I'm gonna abstract, stuff so that, or make it like an accessor or something like that, so I'm not having to inject it. Especially because there's some things that don't necessarily need to be injected because you don't need the instance of an object, you need an instance of an object. So you really just need to think about how your model, like how your models are, how your flow is, and then like, is it actually creating multiple instances, or like, because if I'm okay, so like a good example of this might be like, I have some UI screen, right? And but the data is only pertaining to this UI screen. So do I need to inject a giant, like the like repository into that data piece? Probably not. I can probably just, even on that one, I could probably just do an actual like database accessor and then come back through. Or what I could do is make that come from some other place and just inject the like, and I don't even need to inject it. I just need to pass an instance of an object. I don't need to pass the instance of all my objects.
I would also say on top of that, that if you were going to do like a composite use case that called other use cases or something like that, it might also depend on the composition. Like, if it was more business logic oriented and belonged in domain versus was it more related to the screen? And then if it was obvious, and the more it's domain type logic, at that point, yes, I would definitely consider using a composite use case and have it call other use cases and have some logic in that interactor that did the whole assembly of the data. So like what you did for your server, for example, or create a whole repository just for the purpose of assembling those pieces together, like you did.
He's got
So if you were one of the things, obviously, from doing Androids that's everywhere,
slippers.
one thing I do again and again, obviously you'll never work on a code base that has, that is fully built with clean architecture, right? Some pieces of it will be wild and legacy code, right? So if you you wanted to convert, to a clean architecture, suppose the API layer, and obviously there won't be anyone at any time that's going to give you time to do the whole thing at once, right? How would you go about it? And from your experience, how would you go about it?
One repository at a time, maybe like, pick a RESTful path, for your account or something, or profile, or a few calls, and try to migrate, a small chunk at a time, and go from there.
Yeah, that's a good approach. always follow that approach.
This is like
and,
architecture
yeah.
by committee situation of
Yeah.
everybody who's been doing it for a decade.
Right. Yeah. I was wondering, do you utilize some form of like, you know, if something common I always use is like architectural design records, you know, whatever proposal for, how do you what is your experience? Obviously, I know that all of you have experience with that. So how do you like that?
I'm sorry, what was the question again? I kind of missed
How
it.
do you you know, do you use ADRs in your everyday some type of a proposal, like for whatever you're proposing?
I've pitched clients. I'll usually write up a Confluence page or something simple, and point them to Uncle Bob's web page or something like that. As far as I have been lucky in my career in Android that this probably because Luke gave me all the cherry projects, but I've been lucky in that I've had many opportunities as a lead to actually start from scratch and not have to pitch anything and just get to do what I wanted to. So,
oh man, that's awesome.
Okay, guys, this call is my next machine learning and other call. So this has been a pleasure. Frank, give me 30 seconds. This has been a real pleasure talking with you guys. Mohit, this was a fantastic presentation. I can't wait to talk to you guys more, and I'm going to be much more regular in attending these meetings from now on because it's been such a great experience this time around. So I'm going to have to drop though. It's been fun.
Yeah, it was great talking.
Good night.
Thank you.
All right, bye everyone. Bye, Stacy. Hit me up my email.
If I can ask a question along those architecture lines, I've been trying to sort some of that out myself. You know, you learn some frameworks and things, and people talk about frameworks like they're architectures, and they're not. And is there a nice like 101 book, like getting started with design? There's a lot of books that people point to in graphic design, but what about architecture? That's not just someone diving down into one particular architecture, but it's like, here's a set of jargon for you to, here's like the short course on it. So you could read it and then turn around and assess and discuss modern choices people are making today, whether it be web app or other.
So, I mean, different architectural patterns kind of follow different domain spaces. So like in Android, it was, old days, right? MVP, model view presenter. Then we all went, woohoo, MVVM, model view model. That doesn't sound confusing at all. Model view model. Okay. And then now the latest kind of pattern that a lot of people have gone into is what is called MVI, model view intent, and making sure that there's another, I'm going to throw another one at you called unidirectional data flow. So when Mohit was specifically talking about, and Colin was asking, oh, so you've got it all going one direction, right? That's that architecture pattern, which plays into MVVM and MVI, is called unidirectional data flows.
Right, like React.
Yeah, to a certain degree, but not entirely. Oh, I got a crying baby.
Bothering your sister?
So at least yeah, no, you can hear all the drama. So on this side of the world, kind of the bigger platforms for listening to kind of what is going on Murmur side and staying in on it is Android Weekly and Kotlin Weekly from the Android side of things. I know that dev.to is extremely popular on the web side of things. for what's going on pattern wise, and you'll see a bunch of things. You just have to be careful, just like with Android dev. So hashtag Android dev. There's a few, we'll just say unscrupulous, basically advertisement companies that just steal everybody's content and then spam the hashtags. So that's, and some of it can be totally wrong and doesn't work. So, you know, those are like actually reliable sources is what I would say.
Yeah, I stick to core technologies, and then I listen to lots of people until I can understand where they're telling me wrong. And then I figure I might know a little tiny bit, and I find someone else, you know. But yeah, it's interesting. Everyone says they can, and not very many people can. Not to be rude about it.
I talk a better game than I program. I feel like I'm better at architecture than actual coding. Now is what I'm gonna go say. Like, just,
I have the bug. I never thought rolling up my sleeves and coding would be so addicting, and I think it's something I avoided my whole life, but I had early exposure to it, and I'm just like, damn it, I like to code. God, you know,
it's the act of creation.
Yeah. I do create other creative stuff, and it's got to be the most time-consuming thing ever, but it's a lot of fun.
And you only get better at it. It's and then once you start getting better and you start sharing, then you get into like a whole other level, and it just, you know, it all builds and pyramids up until you are this either god level programmer or you've ascended to a whole new pyramid. So
I can only dream. I've got a little something that I was trying to figure out how to monetize it, and you know, and I think ultimately the answer is to give it away and have a whole array of capturing the generated demand, you know, or the attention or the mind share. But it's so hard when you're trying to do something on your own. You have to do all this stuff that doesn't scale, and then you're trying to do product at the same time, and then you're trying to carve out just enough space where you could deliver some value. And it's anyway, it's nice that you guys have late hour stuff like this, and thanks for letting me sit in.
Yep. The only thing I have to say about that is, do you think that Uber ever intended to make money off of cab rides? You know?
Yeah. Well, thanks for your time.
Yes. Well, thank you for coming, Raul. It's what makes it a successful meetup is having people attend. And I know we've had pretty much everyone else kind of drop off as the night goes on, but I'll just say thanks again, Mohit. Great presentation, great interaction. Lots of great content here, and we just really appreciate you speaking again at GDG Dallas, and we look forward to the next time.
I have more questions, and one day someone will answer them. No, I enjoyed the Q&A. I mean, asking questions on things I think about every day.
Yeah, that's great to have that community. We'll wrap up here, and then maybe we can stick around a little bit for the after party, I guess we'll call it.
All right.
Thanks, Mohit.
By the way, will you when will you stop the recording?
I'm about to. I'm just trying to wrap it up.
But God, I kind of hoped you already did.
No,
I was hoping that too. I was going to ask you, will you cut out all the questions?
Yeah, you can cut all my stuff out too if you want. I'm good, but
I mean, I can. We'll see.
No, I don't have a problem being like, hey, this is what I've been told, and I don't like it. Although I really do think that, like, we're going to be presented with some sort of pattern at some point or tool for really like abstracting out some of the stuff on the view model to really get it better for state for compose. And the navigation compose thing gets real hairy too. It's not quite as hairy as the app graph stuff, but it's not. But at least it's not fragments. There's that. Fragments.
To flutter or not to flutter. So
that's the next one.
You know what? Yeah. Honestly, though, if you were doing something on your own, like Flutter's probably like the way to go because their UI code, desktop code, iOS, Android code, it's all basically the same code. Like there's not really much to build out to new platforms. Like especially not compared with like other multi-platform platforms is a way to say it. And like remember, even on KMM, right, multi-platform, multi-mobile, that does not include UI.
Right.
So although I have seen some very fancy people who've built some stuff that allows the UI, but they're very fancy, and I'm not. Did you not see my two kids situation? Like,
I don't, those look like pretty complicated constructs.
I know, it's
Right.
like weird.
Some serious AI.
Right,
So-
yeah. But you never know. I do have my like official tech bro like wool hoodie on, so I'm ready for business. This is business professional attire over here. That's how you know you got what you paid for.
I'm like in the virtual world. It's nice with its blurry backgrounds and all that. So, anyway, good night, everyone. Thank you for your time.
Thank you. And thank you very much, Mohit.
Thank you.
Thanks for coming.
Thank you.